Hello and welcome. In this series of videos, I'm going to teach you how to make interesting and hopefully compelling music with the OpenAI Jukebox AI. It's fairly complicated and all, but it can be mastered with patience and a little determination. In this video, I'm going to teach you how to unmix music and make use of it in Logic Pro. After you master the content of this video, you'll be able to take a recording of a band or whatever, some ensemble of instruments playing together, and unmix the vocals, drums, bass, piano, electric guitar, acoustic guitar, synthesizer, strings, and winds as you see fit. This comes from a very cool innovation in AI that it's possible for a properly trained model to listen to a polyphonic recording of many instruments playing simultaneously and, with varying degrees of quality, extract vocals, different instruments, and so on. We call these split-out tracks stems, a commonly used term in music production. Pulling out the stems benefits many sorts of musical activities. It's a huge boon to people who are trying to figure out parts. Isolating a guitar or keyboard, etc. can make figuring out a part considerably less difficult and can leave you with a lot more confidence that you've got the part right. As well as extracting a specific track, the model can extract the backing track, that is, everything but that track. This is super handy for practicing and playing along with the recording. For example, a drummer can isolate the drum track and also get the ensemble recording with only the drums removed. They can listen to the original drums standalone or, since they're now in separate tracks, have the drums at a different volume level than the rest of the piece, or of course, mute the drums entirely. A stunningly good drummer and friend of the channel, Frog Pond, separated the drums from the rest of the song of Game of Inches by the Big Fat Band. Here we have 3 tracks in Logic: the original track, the extracted drum track, and the backing track. Let's have a listen to a little of the piece. Here's a brief extract of his recording. The drums are all him and only him. Another use, and the reason why unmixing is a part of this series on making music with OpenAI Jukebox, is to improve the quality of the sound of the stuff you get out of Jukebox by adjusting the mix, adding EQ and compression, etc. The sound quality out of Jukebox is not great, and there are good reasons for that, and it's not something that's going to be easily fixed anytime in the near future. Also, usually the structure of the tunes it makes leaves something to be desired, even with co-composing, and its melodies are frequently uninspired. So it's unlikely anything that comes out of it directly can be tweaked into a masterpiece. The real value is to spark your imagination, and anything that's going to be of competitive sound quality to what people are used to is going to have to be re-recorded from scratch. Nonetheless, improving the sound quality of what comes out of Jukebox can make a big difference in the perceived quality of the song. Splitting parts into tracks can help make them easier to figure out. Plus, it's fun. I've got to warn you that the results can be highly variable, from amazingly good to really lousy. Sometimes an instrument will get pulled into the wrong stem, like a distorted organ might come out in the electric guitar track. These are constraints that we have to deal with and adapt to at the current point in time. We can expect the technology to continue to be improved. Usually the drum, vocals, and bass come out well, but any of the tracks can be hit or miss. The amount that's going on in the piece, distortion, reverb, echo, etc. can have a big effect on the results. There are a number of sites that will extract vocals and vocal backing tracks, including for free. The only site I know of that can do stuff like electric guitar, synthesizer, piano, bass, drums, etc. is lalal.ai. That's LALAL.ai. Lalal.ai charges for their service and requires you to register and get an API key. They currently charge $15 for 90 minutes of splitting, with tiers leading to big price drops for larger purchases. They run sales fairly often. Their most expensive tier without discounts is about 17 cents per minute. Prices fall rapidly if you buy larger increments, down to as little as 6 cents per minute. You pay by the minute per stem and backing track combo. That is, it costs no more to get the stem and backing track for one instrument than to get just one of the two. So for example, if you wanted to extract 5 parts from a 4-minute song, you will be charged for 20 minutes, somewhere between $1 and a bit over $3, depending on the plan you purchase. Okay, so you can use their website, but it's a pain. It can only extract stems and backing tracks in pairs, so one pair at a time, and for each stem you want to extract, you have to go through the web page and upload the file repeatedly. They also have an API, or Application Programming Interface, which is a way for computers to talk to each other and to run programs remotely, get results, access data, etc. They have a Python program you can run on your computer that can talk to the API and do the same stem extraction that their webpage can do. Python is a pretty great programming language and is heavily used for AI. They don't do the actual neural net training and running directly in Python, that would be too slow, but they use Python to set up and orchestrate the activities. This fellow Leonbauer on GitHub modified the lalal.ai program to be able to process and download multiple stems and backing tracks while only uploading the song file once. Further, it overlaps processing with downloading to speed up the extraction process. This really adds up in terms of speeding up the process and really cuts down on the number of repeated actions required of the user to extract several parts of a song. Even with his improved Python program, he felt the Python command line was still a fairly difficult thing to take on and use for musicians and composers who aren't super technical. So he took it a step further and created Unmixer, which is what I'm going to show you how to use and integrate with Logic Pro. So Unmixer is nothing more than a GUI front end for lalal.ai's AI-powered stem splitting technology. It makes it way easier to use. I should note that he points out that Unmixer is not associated with lalal.ai, that it is a personal project to help make music tools more accessible to musicians and composers. How to install Unmixer. Go to github.com/Leonbauer/Unmixer. Go to Releases, find the latest release, and download the .dmg file. Once it's downloaded, open the .dmg file from your Downloads folder by clicking on it. Now drag the Unmixer icon to the Applications folder. That's all there is to it. How to run Unmixer. Double-click on the Unmixer icon. Depending on how macOS is configured on your machine, you may not be able to do this because Unmixer is not a signed application that's been blessed by Apple. If macOS gives you a security warning and refuses to launch it, Control-click the icon and select Open, and then from the security warning, you can approve running it. macOS will remember this permission and you won't have to do it the next time you open the app. The app can't do anything until you go to lalal.ai, register, and acquire an API key. Paste your key into the API key field in Unmixer and hit Save. Don't share your key or post it to the internet or someone will be able to steal all your minutes. Unmixer will make sure your key has the correct format, but if the key is wrong, it definitely won't work. And if you get an error when you try to extract, this is the first thing to check. Next, pick the song you want to extract stems and/or backing tracks for by hitting Pick next to Input File and use the file browser to locate and select your song. Most audio formats will work. Of course, you should use the highest quality recording that's available, preferably something uncompressed such as WAV or AIF rather than MP3, but whatever you've got. Note that on the Mac, you can drag a file from Finder into the file browser, which will cause the file browser to change to that folder and select that file, which can be really handy in place of having to navigate around a bunch in the file browser. If you already have the file in Logic Pro, like for example, you used the technique in our earlier video to record the output of an application in Logic, you can navigate to the audio files folder in your Logic project, assuming you saved your Logic project as a folder instead of a package. I recommend you save your Logic projects as folders. When saving, you have the option to organize your project as a package or folder. You can convert projects saved as packages to folders manually by opening the project and choosing Save As, and then picking Folder as the organizing method. Next, pick the folder you want to save the extracted stems and/or backing tracks to by hitting Pick next to Save To. The Save To folder is sticky, so it will be set to the same value whenever you start Unmixer until you change it. Don't save directly to the audio files folder in one of your projects. Logic will save the file there for you and manage it there when you drag it into the timeline. Save it in its own folder, somewhere where you won't forget. Click on all the stems and backing tracks that you want to extract. When you've got everything set, click Run. Unmixer will show its status in the status area and the status of the individual extractions as they move through the process of being extracted and then downloaded. An indicator next to the status area will slowly move left and right to show that it's working. However, if something breaks during this part, the indicator might continue to show movement when it's not actually doing anything. I understand the program is pretty new, and new programs tend to have problems, but as long as it gets some attention over time, it will eventually become robust, to whatever degree it isn't, which, well, it hasn't failed me yet. It can take a few minutes, particularly if you've got a long song, a lot of tracks to extract, and/or a slowish internet connection. If all goes well, the status will conclude with All Done, and all your stems and backing tracks will be present in your Save To folder. Great. Now we want to get the tracks into Logic. It's important that the lengths of the tracks and their starting points are the same so that the time alignment between the tracks is inherent and you don't have to try to align them by listening and manually aligning them to each other. If you use Logic to create the original recording in the first place, pull it up. If not, then create a new project and drag the original recording into a new track. Now, in Finder, Shift-click or Option-click all your new tracks and drag them to the timeline in Logic. Make sure you align them with the exact starting point of the original track. It may help to zoom way in with the horizontal zoom to make sure the alignment is correct.
Pop-up offers choices of creating new tracks, using existing tracks, or placing all files on one track. Choose Create New Tracks. It may take a minute to import the tracks. You can see Logic working through the importing of the tracks, constructing the waveform visualizations, etc. If a part isn't very loud in the ensemble recording, then the levels of the stem won't be very loud either. Let's normalize the volume of the stems, then we'll control the mix with the sliders. Normalizing is non-destructive. That is, it doesn't change the values of the samples in the audio files. First, we'll double-click on one stem to select it and open the track editor. If it shows File or Smart Tempo, click on Track. Then go to the Functions menu and select Normalize Region Gain. You should see the waveform display thicken if the level was low enough that normalizing it significantly increased its volume. From there, you can select additional regions and apply normalization by hitting Ctrl-G. Alternatively, you can select all the tracks and normalize them all at once. There are some options, and there are some pretty good videos online that explain them and demonstrate the various options. Now let's listen to various parts and see how well the splitter did. And also we'll make sure things are in sync. Alright, things are in sync. Now it's common to hear something like aliasing and various weird sounds and artifacts in tracks where the model thought it heard some vocals and there really weren't any, things like that. So listening to the track, if you want to use it for something, it's a good idea to silence parts of the track that aren't musically useful, which you can do by stroking in the track editor and hitting Ctrl-M to mute the section, again non-destructively. We can now carefully make use of the split-out tracks for various purposes, including improving the sound of the things we make with OpenAI Jukebox.